Assalamualaikum and hello. In this video, we are going to focus the second part of Chapter 1, Introduction to Organic Chemistry, where I'm going to teach you about structural formula. Structural formula is a formula that shows how the atoms in a molecule are bonded to each other. So, what you have to understand, there are three types of structural formula, which are the first one, expanded structure, or another name we call it as dash formula. The second one is condensed structure, and the third one is skeletal structure. The most important thing is the basic skill that you need to have in order for you to understand organic chemistry is the ability to draw the organic compound structures. Let's focus with the first structural formula, expanded structure. Expanded structure shows all covalent bonds between atoms. It means that you have to expand the structure, but it does not represent the actual shape of molecule. For example, I have C4H9Cl. We got 4 carbon atoms, 1, 2, 3, 4, and then we expand with 9 hydrogen atoms, and I got 9 hydrogen atoms attached to each carbon, but make sure when you expand the structure, your carbon atoms will have 4 single covalent bonds because that's the maximum of bond it can form. Next, you got one more atom left, which is chlorine atom. You just put at the second position. Then, the name of this expanded structure of a molecule is 2-chlorobutane. Now, I got propane with C3H8. This is the expanded structure for propane. The next one, I got propene with double bond in the middle of 2 carbon atoms with C3H6 as its molecular formula. So this is how you expand the structure for propene. The next expanded structure is propyne, where you got triple bond between 2 carbon atoms. And the last one, you got cyclopropane in cyclic form. As you see from here, the structure for cyclopropane is just like a triangle. I hope you are clear with expanded structure. Now we are going to focus for the next structural formula, which is condensed structure. Condensed structure does not show the single bond between carbon and hydrogen atoms. It means that you have to get rid the single bond between these two atoms, carbon and hydrogen atoms. The next one, you have to show the double bond or the triple bond. And all atoms that are attached to carbon are written immediately after that carbon. This is the best way to start from the left side of the molecule. If you got 2 or more similar groups bonded to the same atom, your condensed structure of that group is written in brackets, and a subscript numeral with number is used to indicate how many of the groups that same atom has. For example, when I want to write down C4H9Cl, when you expand the structure, you will get the structure as before, just like this one. But when you want to write the condensed structure, you will start from C, from here, with H, you got 3 of them. And then you got C for the second carbon with H and Cl, and you got C for the third carbon, CH2, and the fourth carbon you got C with 3 hydrogen atoms. That is why the condensed structure for C4H9Cl is going to be just like this one. The next one, we are going to use the bracket in condensed structure. What is the example for that? I got propan-2-ol with its molecular formula C3H8O. So you got the expanded structure for this molecule. The best way to start drawing the condensed structure for the molecule, you need to start with expanded structure. For this case, I expand already C3H8O. And what can you see? You can write it down as CH3 for this one is referring to this one. And the next one, you got CH, and this is CH, but connected to this carbon, you got OH group. So that's why you got one single bond for OH. And why I put this single bond, even though in condensed structure you don't have to show, because this OH group is a functional group. So you need to show the functional group in condensed structure as well. And the next of it, you got another CH3, which is this one, indicates for this one. The next condensed structure that you can write in another form, you can start with CH3 is referring to this one, and then you got CH in bracket OH. This is where you use the bracket in your condensed structure. So what will happen, you will get in this form. But make sure you put carbon first, followed by the group of atoms or atom attached to the carbon that you put first from the left. And the last one, you got CH3, which is referring to this one. The next one, you also got the same form as above, but without the bracket, also acceptable. And the last one, you also got CH3 for this one. You got two of them, and then you got CHOH. This is what referring to the second carbon. So all of these four different forms are acceptable for condensed structure. So please make sure when you write the condensed structure, you will start from left to right. I also got another example, 2-methylpropane with C4H10. You can see that we got the expanded structure for 2-methylpropane, and make sure you use the bracket to indicate a similar alkyl group bonded to the same atom. For example, I got the same atom is this carbon in the red highlight. And what's next? I'm going to put the same groups of CH3 with numeral subscript. As you see here, we got CH3 in bracket with 3 of them. And also, you can write it as manual from before, starting from CH3 here, this one, and then CH, and then CH for this one, and then you got CH3 attached to the second one, and you got CH3 with the last carbon on the right. The next one, you can also use the bracket for the repeating structure. For example, I got octane, and you got too many repeating structure for CH2 based on this condensed structure. What can you do here? You can put another form of condensed structure with numeral subscript for CH2 starting from CH3. So we got CH3 here, is referring to the same one from here. And then CH2, all of them based on this one. And you got 6 of them. You put in the same bracket with numeral subscript 6. And after that, you got another CH3. This one is referring to the same one as this. So there are two forms that you can write for condensed structure of octane. The last one, for example of condensed structure, for single atoms such as halogens, you can put bracket or not. So this is one of the example for functional group with single atom. So as you see here, you can put the bracket just like the second form, and you can also write it as bonded to the carbon. For the second carbon, you got chlorine, just like this first form. Or you don't have to put the bracket, and you can also group CH3, the similar group of atoms, at the same point, just like the last form. So these all are acceptable for your condensed structure. Now, let's focus with the last structural formula, which is skeletal structure. Skeletal structure does not show C and H atom. So how you want to do that? Carbon chains are drawn in zigzag, but the rings are drawn as polygons. The next one, you got C atoms assumed to be at each of the two lines and at the end of each line. So what can you show from here? You can use covalent bond by showing a line, such as one line for single bond, two lines for double bond, and three lines for triple bonds. And the next requirement for functional group, such as OH group, need to be shown. And other atoms such as O, Cl, and N atom, you need to show as well. So how you want to indicate that one? Let's see this example. From here, you got an expanded structure for one molecule. So I'm going to give the number for this structure. As you see here, I'm going to start here from 1, 2, 3, and 4. And this is going to be carbon number 5. So how you want to indicate? Based on skeletal structure, we cannot show carbon atom and hydrogen atom. So it means that you need to indicate by using points. So now I'm going to write my first carbon as 1 point. So this is my first carbon. And in zigzag form, I'm going to draw my line connected with another second carbon. So this is my second carbon. And another zigzag form, we are going to connect with the third carbon. And as you see from here, between carbon 1, carbon 2, and carbon 3, all of them are single bond. So that's why I'm going to draw just one line. And the next one, I'm going to connect carbon 3 with carbon 4 in zigzag form with another one. So this is going to be carbon number 4. And the last one, you can use one more dots to show carbon number 5. This is carbon number 5. So what can you see? This is the skeletal structure for this molecule. So I hope you are clear how to draw this one. The next one, you can also draw in the normal way as this one and this one. This is also acceptable. This is also acceptable. Either you want to show the dots or you don't want to show it. At least I can see the pointed form here is indicating the carbon atom. Now let's focus with the next structure. For this one, cyclopropane. Now let's focus with the next structure. This is the expanded structure for this molecule. What you have to show, you are going to draw the skeletal structure. Make sure you cannot show carbon and hydrogen atoms. But another groups such as OH group, or another name for this is hydroxyl group, is a functional group. So of course, you have to show the functional group. But make sure you put the bond between this carbon and this oxygen. So that's why you can draw it just like this form for skeletal structure. The next one, you also got CH3NH, CH2, CH3. This is the expanded structure for another example. What can you show here is only the other atoms apart from carbon and hydrogen. As you see here, you got N atom. This nitrogen atom is attached together with H atom. So of course, once you got different atoms apart from carbon and hydrogen, you need to show it. But if it comes with another hydrogen, just like this case, you have to indicate the hydrogen as well. The drawing for the skeletal structure for this molecule is going to be just like this one. And for C and H carbon here, you cannot show it. Just put the dot or the normal line. And same goes for these two. And final thing, how you want to make sure you get the correct skeletal structure, I will give you a tip where you have to outline the carbon skeleton first. So you have to separate the number of carbon atoms in that molecule. For example, this one I got This C is referring to this one. This is CA, this is CA, and then CB, and then D, and then you got E, and then you got F. This indicates carbon E and carbon F, and you got carbon B and carbon D. So that's why once you outline the carbon skeleton first, just like this structure from here, now you can straight away draw the skeletal structure for this molecule. And make sure for single atom just like halogen, you have to show with extra line that indicates the bond between carbon D and this Cl atom. And the next one, you got the double bond. So of course the double bond can be indicated as 2 lines, just like this one. I hope you are clear with how you want to draw the structural formula for 3 different types. The first is expanded structure, the second one is condensed structure, and last but not least, skeletal structure. So I hope you are clear with this video. That's all for this one. For the next video, I'm going to see you later on. That's all from me. Thanks for watching. Bye.